event source, decoupled, desynchronized sensor. Can we do something similar, event-based, asynchronous type of system? Our lives, almost everything we do is asynchronous, especially when it requires cooperation with other people. Yet, we tend to design our systems to be synchronous. Why is that? Why do we do that? If you take me as an example, when I publish a video on YouTube, I do not know who will watch it. I do not know when people will watch it. I do not know how many people will see it. And that is not important. I mean, it is important, but we get to that later. As a publisher, my job is to publish a video. And I do not know who will do what and how with it. That's not part of what I'm doing. I'm a publisher. You, dear person watching this, you're a consumer. And our tasks are asynchronous. They're event-based. I'm a publisher, you're a consumer. And then the roles might change. You might write a comment and then you become a publisher, and I might read that comment and then I'm a consumer, or I might not. There is no guarantee, there is no synchronous process between those actions. We perform some action, we create some event, and then we continue with our lives. That's how we operate in a real world outside of software engineering type of setting. Our systems should do the same. Some processes should be publishing events, and then some other processes should be listening to those events and doing something. But those two actions, publishing and consuming events, should be decoupled, desynchronized, are not directly related with each other. A process publishing an event doesn't need to know who will consume it. And the consumer doesn't need to know who published the event. Those things are decoupled in real life, and we should try to do the same for our systems. That is how Kubernetes works. When we execute kubectl apply, we are telling the system that, hey, there is this event that something wants to create this object or to update this object or to do something with some resource. And then there are completely separate processes inside of the cluster that consume that information and do something with it. But when we execute kubectl apply, we do not wait until that something is done, that something is created, updated, what's or not. No. We get only the acknowledgement. Hey, I received your request. Something will happen sometime, but for you, the only thing you should know is that you got acknowledgement that I understood what you want. Go away, do something else. For example, if we create a service mesh interface or SMI type of resource, we do not necessarily know whether it will be Linkerd or some other controller that will do something with it. We might know because we designed the system, but that's not really the job of the publisher. We're just telling Kubernetes, hey, I want you to have this and that, and then let something else take care of making that happen, and in a very asynchronous way. We get acknowledgement, and that's about it. If we want to know the state of that something, if we want to know what happened, we need to query at some later moment the system and see, hey, did this happen or not happen? But publishing an event is only giving you the acknowledgement and nothing else, because it is event-based, asynchronous, and so on and so forth. And now comes the question. Here is the important question. Can we do something similar to our components, our applications, our system? Can we create events without worrying who will listen to those events? And can we create consumers without worrying who will publish events? Can we make those operations completely separate and decoupled? And the short answer is absolutely yes. And there are many ways we can do that, but today we're going to explore how we can create event-based architecture or processes using Argo Events. We are about to explore Argo Events in 20 minutes. or less. The only thing I prepared in advance is a Kubernetes cluster. I will be using Minikube, but everything I'm showing you applies to any Kubernetes basically, so it doesn't really matter. As long as you have a Kubernetes cluster, you should be able to follow along. And here is the important part. If you do want to follow along, all the commands I will be executing are in a gist, and gist, the link to the gist is in the description or the comments section. So go there, get the gist, copy and paste the commands and all that jazz. So the first thing I need to do is to install Argo Events. It can be done in quite a few ways. Preferable way is to use Argo CD to basically manage everything in your Kubernetes cluster, including Argo Events. But today I will not use Argo CD for a simple reason, because I want to go with the simplest possible solution. That will be kubectl apply, 1 or 2 kubectl applies, and that's it. Going simple. You shouldn't do that in production. Use Argo CD. And if you don't know what Argo CD is, the link is above my head, somewhere up. You will find the link. So just go and follow that if you're not familiar with Argo CD. But not today. Today we are going with the simplest possible installation. That is a couple of steps. First, kubectl create namespace Argo Events. We need the namespace where we're going to install everything or deploy stuff. And come on, there we go. And then we need to apply a couple of definitions. Specifically, first we need to create custom resource definitions for Argo Events. So that's kubectl apply, and then file name, and this long address. This is the official project maintained definition manifests for all the CRDs. Actually, I was wrong. That's not CRDs. It's CRDs plus RBAC plus deployment for the controller. Basically, it's almost everything. Everything. Think of it as everything. But everything except one thing. We need to install also event bus. I will explain later. I might even draw on a screen what all the components are, but I will do that at the end. For now, just trust me. Apart from the base installation, we need event bus, and I will explain later what event bus is. So kubectl apply, and then the namespace where we want to apply it is Argo Events, and we want to apply something available in a file which is on this address. As I said before, it's in the gist. So just go there and run it. Come on, come on, come on. And there is only one step missing. I think it's only one step missing. We're going to clone a repository, git clone, that I prepared that has sample demo manifests or sample application, what's not. The things we will need is in a repo that I prepared for you, and that repo is in https and then github.com, and it's me. It's my repo, and I think it's called Argo Events demo.git. There we are. That's the one. Oh, not found. That was silly of me. I'm missing the T here. Argo Events. There we are. Now it should work. There we are. Hey, typo. Everybody makes typos every once in a while. So I'm going to go to the directory where I cloned the local copy of the local clone or local copy of the repo. And that's about it. Now we can dive into creating events and publishers and consumers and all that stuff. All that jazz comes right now. When we talk about Argo Events, we normally talk about 3 different components or pieces. One is the event bus. That is the one that we installed a minute ago. It's the one that manages all the events. It is basically a bridge between event sources and triggers. And now I already mentioned the other 2 components, and that's event sources and triggers. Hey, event sources are sources of events, entities that publish some events, and those event sources can be many different things. I'm going to show you later a list of what can be event source, but for now think of it as a publisher of some event. And then we have triggers, and those are entities that will trigger certain actions depending on events created through event sources, right? So publisher and consumer in a way of events. Now let's create our first event source. There can be many different types of event sources. We're going to go with simple one just to demonstrate how it works. So we're going to create a webhook as the source through which we can generate events. So let me show you a definition that I created earlier, event source, and this is the simplest possible one, just to demonstrate how it works. So we have here an event source, cool, a name, we're going to call it webhook. Webhook means that we're going to expose an entry point in our cluster through which we can send HTTP requests that will receive events, right? That will become the source of our events. There can be others. My favorite, for example, would be Git or GitHub or GitLab webhook as event source. There can be many others, but we are going simple, just HTTP webhook or endpoint. And what do we need for that? In specification, we need a service in our cluster that will watch for expose a port, and the port it will expose is 12,000, and as a port, 12,000 as a target port, and then we have the type of event. And in this case, the type is webhook. There can be others. I will show you the others in a few moments. The list of all the currently supported event sources. But we are using webhook as event source, and then we can have one or more specifications inside. And each of them starts with a name. In this case, it's called DevOps Toolkit. It can be any name you want. And then the port through which that webhook should be exposed, the entry point, which in this case is slash DevOps Toolkit, and finally the method, which is set to post. And if this works fine, we should have the source through which we can generate events, and that source will be webhook. It will accept HTTP requests. So let's create that one, and that's kubectl -- namespace Argo Events. What do we want to do? Apply something defined in a file, event source YAML. And there we go, it is created. A couple of things happened. First of all, if you do kubectl -- namespace Argo Events, we can see that an event source was created. Get event source, right? That's the one we just created. It's called webhook. And that event source created a few things for us. And one of those things is that it created a service. Here we are. You see this one, webhook event source, as we see. That's a service that was created for us. And it exposes port 12,000, internally, right? We should normally create now ingress controller that would manage incoming requests from outside of the cluster on the cluster IP 12 and the port 12,000. But we're not going to do that. I don't want to now dive into ingresses and what's not. So we're going to do a simpler way, and that is to port forward to the pod. So we're going to, let's take a look at the pods we have here. Here's the one that was created for this event source. So I'm going to copy the name of this pod, the name that was selected, and store it in environment variable, event source pod, or not pod name equals this, right? So to port forward, I'm going to execute kubectl. This is boring, namespace Argo Events, and then I want to port forward. Don't do this in production. This is just a replacement, opening the port on localhost instead of creating ingress. Anyways, port forward to the pod event source pod name, and the port is 12,000, and it will be exposed as 12,000 on my localhost, and I want to run it in background. That's the ampersand at the end, right? Okay, cool. Now I'm having access to that service, and I can see what can I do with the webhook that was just created for me. I can, for example, send UCURL curl to send a post request. Remember, we specified that we want to post. And then as a header, I'm going to use content type to be, what is it, application/JSON, right? And what else do I need? I need to send a payload, some message of the event, basically. I'm now sending my first event as a webhook, and that message will be, what will it be? Message, I'm using JSON now, and that's the key, and the value will be my first webhook. That's it. Let's see whether this works. Did I forget anything? Oh yes, I forgot the most important thing. And the address is HTTP localhost and then 12,000. And we said that the entry point, that's what we specified in event source, is DevOps toolkit, right? Now, there we go. We got success. See here, it says success. So the system successfully accepted an event that contains the message my first webhook, and the event is the webhook type of event on the port 12,000 and the entry point DevOps-toolkit, right? Now what is curious about this is that we got the success, and yet we did not define any trigger. We did not define what will happen when somebody creates this event. We didn't do that. And that's normal because those things are decoupled. When the system responded with success, that means that is, let's say, acknowledgement. Hey, I got your event and that's successful. I understood I received the message successfully. I do not know whether there is anything listening on those events. Maybe there is nothing, maybe there is something. That's not my concern. The success means I successfully received the event, not that, hey, I did this, I did that. We don't know that. And right now, there is no trigger, there is no sensor that will do anything with this event. So success means, hey, I got the message. Nobody is listening on those events, so nothing really happens inside of the system. Now, before we move on, let me show you this page in the documentation. Here we are, this page over here. Let me make it bigger, right? Now, those are the type of event sources we can create, right? It can be Minio, it can be calendar, which is cron-like type of things. A file generation of a file, or some action on a file can be an event. Resource creation or any action on a Kubernetes resource can be an event. Webhook, that's the one we used so far. AMQP, Kafka, MQTT, NUTS, let me make it bigger. NUTS, SNS, SQS, PubSub, GitHub. GitHub can also be an event source. It can be sending us notifications that somebody created a pull request or merged something or what's not. It can be GitLab, it can be HDFS, Slack, Storage Grid, Azure Event Sub, Stripe, Emitter, Redis, NSQ, Pulsar, and finally, it can be generic. Generic means, hey, generic. That's the one you're supposed to extend if you want to create your own event sources that are not covered as one of the event sources I mentioned already. The link to this page with the list of all the event sources is in the description. So anyways, we created an event source that is basically accepting events as webhooks in this case, and we are not doing anything with those events. We are just receiving them so far. Let's change that. Let's change that by, let's say, creating a sensor. You don't know what sensor is. That's normal. I'm going to explain to you what sensor is in a second. And the best way to explain what sensor is to show you one sensor. Here we are. It's a big one, isn't it, right? So here we are at let's go at the top. There we are. Here we are creating a sensor. It's going to be called webhook, mostly because I don't have enough imagination to think of a clever name for it. And then we have a service account name, which is Argo Events SA. That's the service account that was created when I installed Argo Events, which has decently wide permissions to allow me to do what I'm going to do. You don't know yet what I'm going to do, but I'm going to show you in a second. And then it has some dependencies, right? And this is basically what connects this sensor, this trigger, with the event source that we defined before. So basically, dependency of this sensor, let's say a trigger in a way, is the webhook event source that we created before. So whenever somebody sends webhook event, this sensor will be activated. And the name of that event, because if you remember in the webhook event source, we can have one or more events. We defined only one, but there could be more. Anyway, the one that we are talking about right now is called DevOps Toolkit. So that's a sensor that will connect a trigger with event source. And the trigger is defined here in the template. So let's imagine for the sake of argument that whenever somebody sends a request on a webhook, we want to create a pod, right? We want to perform some action in our Kubernetes cluster, and that action could be to create a pod. And this is how we would do that, right? We would create a trigger in this sensor, and the type of the trigger is K8S. There could be, just like there are many different types of event sources, there are different types of triggers. And in this case, we want to create a pod. And the definition of the pod that we want to create is defined in the source section or source resource. So we are creating a pod here using API v1. We are going to generate name payload dash. What that means, that it could be a name, it could be a fixed name, but then there would be some clashes over there. By using generate name instead of just a name, we will let Argo Events auto-generate name that has this prefix. So it will be payload dash some random hash. And the rest is a typical pod specification, right? We are not, this is exactly the same specification except for generate name as we would use for defining pod normally, right? It's going to have a container that has a name hello based on Alpine image. It will echo the message. This is the message you sent me, and then nothing. Now, the second argument is nothing, and this is critical. This is important. Remember it. I'm getting to it in a second. Finally, we have some parameters for this trigger. And those parameters are the payload dependency name. If you go back up here, you can see that we have this dependency payload, which depends on a webhook that we created earlier. So we can use that as the parameter. So I'm going to take the body and the message of that body from the payload, and we're going to pass it to something, and that something is to spec. And pay attention here. Here is spec, and then containers. Here is the containers, and then 0 means the first container in the list of containers, and then args means the arguments, and we want to inject this the message from the payload from the dependency, from the event source as the first argument. Remember, it is 0 indexed, meaning this is argument 0, this is argument 1. So in other words, whatever we send as a message to the webhook that we created before will be injected instead of the empty argument over here. Does it make sense? Are you following me so far? I hope you are. I'm not sure whether I'm confusing you or not. Anyways, let's create that. kubectl -- namespace, and then we want Argo Events, and we want to apply something stored in a file, sensor.yaml. Ta-da-da-da, go, go, go. There we are. What happens if we send CURL request like before, the one that I created before, this one? Before, we were getting acknowledgement that the event, webhook event in this case, was received. Let's see what happens if we, and nothing else happened right before. Let's see what happens now if we send that. And yes, it is successful again. But unlike previous attempt, now we have also the sensor. We have consumer of those events. And we can check that easily by retrieving all the pods. So where are we here? Now let's clear the screen. kubectl -- namespace Argo Events get pods. And you see this one payload? That's the pod that was created as a result of us sending events. So we sent an event. That event was processed by the sensor, and the sensor has a trigger to create a pod. It could be anything else. And if you look at the logs, for example, logs of the selector, what did I use as labels? I think it was app equals payload, I think. Here we are. This is the output of the pod that was created as through the trigger, which says this is the message you sent me, and the output is the message of the payload we sent through the CURL request. There are two important things, very important, left to show you. First of all, here, these are the sensor triggers that we can use. Actually, triggers are here, I think. Or here. Where is it? Here, yes. Here are the triggers. It could be as a result of having a sensor that is dependent on some event source. We can create some triggers, and that triggers can be K8s, which is to communicate with Kubernetes API, which is the one we used. It could create the Argo workflow. Basically, if we use the Argo workflow here, combined with Argo Events, we would effectively have a fully operational Kubernetes native CI/CD system. And by the way, a couple of you asked me to make a video about Argo workflows, and please let me know if that's still the case. I'm very eager to do it. I just want to know how interested you are in Argo workflows. Anyways, it could be HTTP trigger. We could send an HTTP request as a trigger. It could be AWS Lambda. We could do something with Lambdas. It could be custom, meaning that whatever you want. Kafka, NATS, we could send a Slack message. We could do things with OpenWhisk. We could generate some log entries. And Switch, I don't know what Switch is. It's probably not anymore used. It's deprecated. Anyway, and this list is growing as we speak. Now, the most important thing, let me draw a picture of what is happening so that you understand what's going on. The key piece of the puzzle, the most important component here is still is event bus, right? That is the most important thing that we installed in our cluster. And it is important. You will see why here now. Let's jump to the next component, and you will see how event bus matters here. We created some event source, right? In our case, that event source was a webhook, right? It can be many other things. So we created a webhook event source. We could have other event sources that would do listen to some other events. What matters for all those event sources is that they're listening to some events happening somewhere, right? Those events can be webhooks. It could be, what else can it be? It can be some pub sub events as well. It could be something from S3 buckets, SNS. Doesn't matter. It can be many different things. What matters is that event source that we created is listening to some events. And whenever it detects an event, it writes it to event bus. So it goes to event bus. And then we created some sensors, right? Sensors are deciding to listen to something, right? So this is the arrow in the opposite direction. So sensors are listening to the events that were written in event bus. Those are decoupled, right? There is no direct relation between an event source and a sensor. Just as there can be many event sources, there can be many sensors. And sensors are basically listening to the events and triggering some actions. So we have some actions going on here. And those actions can be, like in our case, to do something with Kubernetes resources, maybe to generate some Argo workflows. What else? Can be many different things. It can be something with, I don't know, Lambda, for example. Lambda. You can see that I don't know how to write well. What matters is the sensors are listening to the events that are stored, written in event bus, and then executing some triggers that will do some things. And that's all there is to it. We have event bus, and then event sources are listening for some events and writing those events to the event bus. And we have sensors that are listening to the events written in event bus and executing some action, triggering some operations. And the best example, my favorite example of all that is, for example, using GitHub as the event source that will listen for webhooks whenever we push something to Git repository or create a pull request or what's not, and then sensors that are listening to those events and triggering Argo workflows. And if we combine those two, for example, Argo Events with Argo workflows, we have a fully operational CI/CD that is cloud native, that is designed around events, that is cloud native, Kubernetes first, designed for Kubernetes and all those things. Basically, potentially, and I'm throwing it out there, Argo Events combined with Argo workflows is probably the most advanced and potentially the best CI/CD pipeline type of solution we could have in Kubernetes. And that is just one of the examples of what we can accomplish with Argo Events. It allows us to build systems based on events and orchestrate what will happen, when will happen, but in a asynchronous, decoupled way. Now, I already mentioned a couple of times Argo workflows. And the reason, I have a hidden reason why I'm talking about Argo Events, because I want to talk about Argo workflows next. And Argo Events are almost a prerequisite of Argo workflows. So if you would like to know more about Argo workflows, some of you already sent me comments, keep sending those comments, and I will create a video about Argo workflows. For now, you have Argo Events, and you can use them to design event-based asynchronous type of system. So you saw a very quick overview of what Argo Events are. And I will be honest here, it takes some time to wire our brains. It took at least me some time to wire my brain around events and to start thinking in terms of how I can organize everything to be fairly decoupled, asynchronous, and yet everything connected and everything working together through event sources and sensors and triggers. It is not trivial, it takes some time, but the results are amazing. If you do invest in events, it will make your system more resilient, easier to design, easier even to reason with afterwards. So there is an initial investment, there is initial change that needs to happen, but once it does, creating systems, especially complex systems based on events, is very, very rewarding on many different levels. That's it. Please subscribe to the channel. You know what to do. Hit the bell icon, click the like, and all that stuff. It means a lot to you because you get notifications. It means to me because YouTube thinks that you liked it because you did, right? You liked the video. Anyways, so do all that jazz and see you next time. See you in the next video. Cheers.